My name is Raghav Arora, and today I'm going to be presenting about solar energy. To start off with, I kind of want to introduce you guys to solar energy. Solar energy is not only a clean and renewable power source, it's also one of the most abundant resources we have. In fact, the sun produces more energy in 1 hour than the entire world consumes in a year. Using this sun's energy, we can actually convert this energy into electricity that can provide electricity for homes, businesses, and even entire cities. Right? This remarkable potential makes solar energy essential in reducing our reliance on fossil fuels and mitigating climate change. Today, I'll share why solar energy matters for our environment, our economy, and even our future as college students. In order to understand more about solar energy, let's begin with the science behind solar energy. The technology relies on photovoltaic cells that convert sunlight, or photons, directly into electricity through a system known as the photovoltaic effect. A typical solar energy system includes a few key components. To start off with, there's solar panels, which are made out of these photovoltaic cells that you see on the right. Now, these basically capture sunlight in the form of photons and produce direct current, DC electricity. Then you have an inverter. Now, the role of this device, which you can see on the diagram on the right, so it's right here, this device converts DC into alternating current, which is also known as AC, which we use in our homes, right? And then we have batteries, and these batteries, the function of them is to store any excess energy for times when the sun isn't shining. So when it's a rainy day or it's cloudy, when it's a sunny day, you'll always have a lot of electricity being generated. But on rainy days and cloudy days, you'll have the backup of the electricity you didn't use on the sunny days when there was a lot of sunlight, and you can use that same electricity to power your home on days where there aren't that much sunlight. Now, there are also three different types of solar panels. There's a monocrystalline panel, which are highly efficient, have a long lifespan, but they are expensive. There's another type, which is kind of the opposite of it, called polycrystalline solar panel. It's cost effective, but slightly less efficient. And then you also have a thin film, which is not that common to find, but it's flexible, lightweight, but it compromises on efficiency. Here's the growth of solar energy in the last decade. So, within the last 20 years or so, solar energy has been increasing exponentially. Leading regions such as China, the United States, and Europe are heavily investing in solar infrastructure, and even developing nations are joining this trend. On the right, I've attached a chart where you can see that in the 2000s, all the way to 2022, the increase in growth is unprecedented. It's exponential, right? And many developing nations, as I just mentioned, are beginning to integrate solar into their energy mix. Now, one of the reasons for that is actually because of the cost trends. The price of solar panels has dropped by nearly 80% in the last decade. On this chart to the right, you can see how the price action has moved. It started with $100 a watt back in 1975, and thanks to our technology and our immense amount of research, by 2021 that number has fallen far below than $0.5 a watt. Additionally, robust government incentives like tax credits and subsidies continue to boost the adoption. Now, not only do these provide a significant discount when you buy solar panels, but they also help make it more accessible for everyone to use, which is a huge, huge part of making and fighting, the impacts and effects of fossil fuels. And a fun fact on the side is that nearly 28% of solar energy is powering California in February of 2025, and that number in 2021 was 17.4%, and just within a short period of 4 years, that number's gone up by 11%. So here's some recent advancements in solar technology. To start off with, there's certain things called perovskite solar cells, and you can see images of them on the right. Now these are actually higher in efficiency but lower in cost. Then you also have bifacial solar panels. These are very cool because these capture sunlight on both sides and they increase the overall energy output. And I've attached a diagram on the right on how they kind of do it. Essentially, solar energy hits, so sunlight hits the solar panel from the front and behind. So directly on the solar panel, and the direct sunlight reflected off the ground back to the panel. And you know b- towards the back of the panel, and essentially this gives it two ways of absorbing photons and converting it into electricity, which makes it a lot more efficient. Additionally, there's something called flexible solar cells. Now these can be used in wearables, portable chargers, and curved surfaces. And these have a vast amount of use cases for your gadgets, your power banks, and so many different stuffs. And of the most important out of all these four are floating solar panels, and these are installed on water bodies, and they save land space and benefit from natural cooling because of the water. Current news update: in December 2024, Science Daily reported a breakthrough in tandem solar technology that achieved record efficiency improvements. This development marks a significant step forward in renewable energy research. Now, let's compare solar energy to the other energy sources. Now, to begin with, they're fossil fuels. Now, fossil fuels are extremely bad, to the environment, and they're finite. And unlike fossil fuels, we have wind energy and hydropower as well. Now, although wind energy is also a renewable resource, its effectiveness is highly dependent on location. Hydropower, while efficient, requires significant infrastructure and can disrupt local ecosystems. Despite the high initial cost, the long term economic and environmental benefits of solar energy make it a very, very attractive alternative. Towards the chart on the right, I've attached on how the solar costs have dropped by a factor of five since 2010. And fun fact: solar energy is, solar and solar panels. Is actually falling in the range of the fossil electricity cost range, right? You can see on the chart, the rate at which the price is decreasing, at least in the US and even globally, is coming very, very close to fossil fuels. Now, despite its many benefits, solar energy also raises some ethical challenges. One major issue is material sourcing. Solar panels require materials like lithium, cobalt, and rare earth materials. The extraction of these materials can lead to environmental degradation and poor labor conditions. Additionally, solar panels have an average lifespan of 20 years, which means managing their disposal and recycling is becoming increasingly concerning. Now on the image towards the right, you can see how the amount of waste, and this is just one of the photos, and this is actually a real photo of a solar panel junkyard. Basically, without effective recycling, we're just going to have a lot of this junk sitting around in our environment, which is definitely not good, considering a lot of solar panels is a lot of different plastics and just electronic junk that we don't want to have. And again, on an ethical side, it shifts consumers away if they know that someone else is being exploited in order to produce these solar panels, right? So we definitely don't want to have another guy, or citizens in Africa or wherever these mines are, being exploited just to manufacture these solar panels. Some other ethical considerations, building on these points, we must also consider the high upfront cost of solar installations. Many potential users find these initial expenses prohibitive. However, there are policy solutions in development, such as increased government grants and innovative financing options that aim to make solar energy more accessible. Addressing these ethical concerns is critical to ensuring that the shift toward renewable energy benefits everyone, not just a select few. So, on the chart on the right, you can see kind of the cost of installation in California by house size. And you can see that for a 1,000 square foot house, you'd need to pay anywhere from 4,880 to 25,680. And, it can go as much as 38,520 if it's a 2,500 square feet house. And this is definitely not something uh, everyone can afford. Now, let's talk about how solar energy is relevant to us as college students. Imagine being able to power your gadgets or even your backpack with small portable solar chargers. Many universities are installing solar panels on campuses, reducing energy costs and serving as real life examples of sustainable practices. Moreover, the expanding of solar industry is creating a wealth of career opportunities, all the way from engineering to environmental scientists. It's all in high demand. Companies like Tesla, SunPower, and First Solar, which are, very dominant in the, solar field, are hiring even more people. And you can see the US solar employment growth by sector. And keep in mind, this is only the US. And in 2010, while this industry only had around 90,000 employees, by 2023, that number multiplied by nearly three times, to a point where it's nearly 280,000 people that are employed for solar energy. To conclude, all the information presented here is supported by reputable peer-reviewed journals and trusted science news sources, and I've cited all my images here. Thank you so much.